Good mythical afternoon. My name's Kevin.
I'm Eric.
And today we're going to be talking about forces and Newton's 3 laws that all forces follow. Newton's first law means that if the net force on something is zero, it will stay still or keep moving at a constant velocity. For example, in space, there are no forces acting on you, so you keep moving at the same speed. The second law states that if the net force on something is not zero, the object will accelerate in the direction of that force. When you're falling downwards, the force of gravity is greater than the force of air resistance, causing you to accelerate downwards. Finally, the third law of motion states that for every force, there is a force of equal magnitude in the opposite direction. When Aang applies a force on the rock exerts a force of equal magnitude back on him, causing him to fly backwards. One technology that uses Newton's laws are rockets. Rockets are objects that are used to propel either spacecraft, vehicles, or other loads upwards, usually into space. Newton's third law comes into play with rockets because when rockets move upwards by burning fuel and expelling the hot gas downwards, the rocket pushes on the gas, and the gas exerts the same force back on the rocket. This is what allows rockets to maneuver in space, even though there is nothing to push against. Newton's second law is also involved here, because as shown in the equation F equals ma, the acceleration is inversely proportionate to the mass. So even though the rocket and the gas are exerting the same force on each other, the gas accelerates more than the rocket, which is why the rocket must emit a huge amount of gas for itself to move a little bit. Newton's second law is also involved with rockets escaping Earth's gravity. The rocket's upwards thrust must be greater than Earth's downwards gravitational pull, resulting in an upwards net force, allowing the rocket to move upwards. This net force must be great enough to allow the rocket to achieve escape velocity, which is 11 kilometers per second for Earth's orbit. Once escape velocity has been reached, as long as the upwards thrust force is equal to the downwards gravitational force, the rocket will continue to move at the same constant velocity, which is Newton's first law. Rockets have had a huge impact on the way our society functions, and we would not be where we are today if we did not have this technology. First of all, rockets have allowed us to put satellites into Earth's orbit. Things such as GPS, phones, weather tracking services, and spying on other countries all rely on satellites. Being in orbit allows these satellites to quickly send signals around the Earth, giving you the ability to find the quickest route home based on your location, talk to your relatives halfway around the world, or track when and where the nearest hurricane is going to make landfall. However, there are many environmental impacts rockets have as well. Since they require so much thrust to be able to leave the Earth, they need to carry large amounts of fuel. Just like cars, they emit greenhouse gases, such as carbon dioxide, when burned. On average, rocket launches contribute around several kilotons of carbon dioxide into the atmosphere every year. However, this is still a small number compared to the amount of carbon dioxide that cars and aircraft emit. One area where they do have the potential to have a significant impact is damaging the ozone layer. With exhaust emitted by rockets, there are reactive gases that can cause ozone molecules to break apart. Currently, ozone depletion attributed to rockets is still very little, around 1% of all human-caused sources. However, with the increased amount of space exploration and the start of the space tourism industry, it is very likely this number will rise. As stated by Darren Toohey, an atmospheric sciences professor at the University of Colorado at Boulder, if left unregulated, rocket launches by the year 2050 could result in more ozone destruction than ever realized by CFCs.
Some improvements that could be made to rockets would be to make the rockets using a lighter material. This means that the mass of the rocket decreases, which in turn allows the gravitational force to decrease. Since the force of gravity is not as strong, you won't need as much force to propel the rocket upwards. The relationship between gas and the acceleration of the rocket is also not very efficient. Another possible improvement would be to use hydraulics to launch the rocket.
Thanks for tuning in. We'll see you next time.
Bye-bye. Okay.
First, oh, it's just still recording.